Today we enter the cryosphere and talk about glaciers and how they move.
What is a glacier?
A glacier, quite simply, is a slowly moving mass of ice that formed by accumulation and compaction of snow. Alpine glaciers, like this one, form in mountains and they flow downhill. Continental glaciers, like you see on Antarctica and Greenland, flow outwards towards their edges. This is a drawing of an alpine glacier with the parts labeled, and there's a few things I want you to pay attention to here. First of all, in the highest part of the mountain is the input area. This is where snow falls and is accumulated and stays with the glacier. It doesn't melt immediately. So we call this the zone of accumulation. Down near the bottom, or the toe of the glacier, sometimes the snout of the glacier, we have an area where the glacier is shrinking, where ice is disappearing by melt or by sublimation, actually going directly from the solid into the gas form. And this is called the zone of ablation. This is where the glacier is shrinking. Somewhere in between the two, there's an equilibrium line where the glacier is neither growing nor shrinking. A couple of other things to pay attention to in this picture. At the front of the glacier, there is something marked as a terminal moraine, and along the sides, lateral moraines. These moraines are deposits of sediment, because as you might imagine, a glacier that is heavy and thick ice that is moving is going to pick up sediment and move it with it. So a glacier does a great job of eroding, and the sediment gets deposited in various places, and we're going to take a closer look at those sediment deposits. First of all, let's look at the erosion end of it. Glaciers form very recognizable landscapes, and one of them is this characteristic U-shaped valley. We talked about rivers before. Rivers form V-shaped valleys. Glaciers form U-shaped valleys, and this is one where the glacier has retreated, and you can see the shape of the valley quite well. This is a hanging valley in Yosemite National Park. You can tell there used to be a glacier here because you can see the U shape, but the rock has broken away, and so now we have a waterfall coming out of that U shape that was formed by a glacier and is now being continually eroded by a river. Glaciers also mark up the rock that they're flowing over. By picking up gravel and boulders and sand and silt and all kinds of things, they become really nice sandpaper on the bottom, and they leave behind striations on the stones that are caused by scraping as the glacier and all its debris slides over. One of the really nice things you can tell from glacial striations is the movement, the direction of movement of the glacier. You can feel the striations and tell what direction the glacier must have been flowing. Glacial deposits are called moraines, and this is a picture of a terminal moraine, a moraine at the toe of the glacier from Greenland. There's the moraine. This is deposited over many, many cycles of the glacier growing and shrinking with summer and winter and leaving this sediment behind. The kind of material that is in a glacial deposit is called till, and this is a picture of glacial till up close. One of the very distinctive things that you see is that the grain size varies from really big to very, very, very fine. So you have mud and silt and tiny particles, and you have really large boulders, and you have everything in between, and all of them are very well rounded. They've been beaten up by this process of transport in the glacier. This is the lower part of a glacier forming a braided stream of glacial outwash. A lot of the very fine silt and clay particles will come out of the glacier with the meltwater and move in this braided way away from the glacier, forming these glacial outwash areas. The water is often milky looking in this region, and sometimes it's a very deep turquoise color. That fine glacial outwash, when it gets dried up, can be moved around very easily by the wind, and this wind-blown deposit of fine glacial silt is called Loess, and this is a picture of it. Sometimes it's forms very, very thick piles around the world. One of the things that's very interesting about Loess is that it tells you something about climate. You know that there were active glaciers if you see piles and piles of Loess of a certain geologic age. This is a map of the glacial coverage during the last glacial maximum about 26,500 years ago. There were glaciers covering a lot of North America and Europe. And this is glaciers today. They're on every continent except Australia. We leave here with a picture of a glacier in Argentina and the toe end of it, where pieces are breaking off and falling into the water. Here is some pretty spectacular glacial collapse recorded just this month, March 2016. Wouldn't want to be in a boat on that water when this thing happened.